Hi everyone, I am Dr. Sarala, Associate Professor of Mathematics. I am going to take Introduction to Fuzzy Mathematics. In this content, I am going to take what is fuzzy logic, and the operation of fuzzy, and what is other examples of fuzzy mathematics. Now, we are going to see the introduction of fuzzy mathematics. Fuzzy mathematics is a branch of mathematics that deals with uncertainty and imprecision. It provides a framework for representing and manipulating vague or ambiguous data, which is useful in various real-world applications. Next, what is fuzzy? The word fuzzy means vagueness. Fuzziness occurs when the boundary of the piece of information is not clear-cut. Fuzzy set, which is introduced by Lofty Zeta in 1965, which is the extension of classical notation set. The classical set theory allows the membership of the elements in the set in binary terms. Fuzzy set theory permits membership function value in the interval 0 and 1. The example for fuzzy: words like young, tall, good or high are the fuzzy. There is no single quantitative value which defines the term young. For some people, age 25 is young, and others, age 35 is young. The concept young has no clean boundary. Age 35 has some possibility of being young and usually depends on the context in which it is being considered. Fuzzy set theory is an extension of classical set theory where elements have degree membership. In real world, there exists much fuzzy knowledge, that is vague, uncertain, inexact, etc. Human thinking and reasoning, that is analysis, logic, interpretation, frequently involve fuzzy information. Human can give satisfactory answers which are probably true. Our systems are unable to answer many questions because the system are designed based upon classical set theory. We want our system should be able to cope with unreliable and incomplete information. Fuzzy system has been provide solution. We will see what is the difference between the classical set theory and fuzzy set theory. Classical set theory, that is the classes of objects with a sharp boundaries. Here, in fuzzy set theory, classes of objects with unsharp boundaries. In classical set theory, a classical set is defined by scripts, that is exact boundaries, that is there is no uncertainty about the location of the set boundaries. In fuzzy set theory, a fuzzy set is defined by its ambiguous boundaries, that is, there exists uncertainty about the location of the set boundaries. The next, in classical set theory, widely used in digital system. Here, it is used in fuzzy controllers. In fuzzy set theory, used in fuzzy controllers. This is the example for fuzzy versus scripts. So, is water cooler? Another one is wrong, honest. In scripts, it can be changed, that becomes yes or no. The next, in fuzzy, is wrong, honest. In fuzzy, it can be various tones, that is extremely honest, very honest, honest at time, extremely dishonest. The 0 and 80 are nothing but the grade of fuzzy. Classical set theory. What is classical set? A set is any well-defined collection of objects. An object in a set is called an element or member of that set. The sets are defined by a simple statement describing whether a particular element having a certain property belongs to that particular set. A, capital A, which is equal to the set of A1, A2 and so on, AN. This is classical set. If the element AI, where AI which is equal to 1, 2, 3 and so on N of a set capital A are subsets of universal set X, then set A can be represented for all elements X which is belongs to capital X by its characteristic function, that is X, A of X which is equal to 1 if X is belongs to capital X, that is that element which is belongs to the universal set. Otherwise it becomes 0 because the element is not belongs to capital X, which means the element will not belong to the universal set capital X. The next, operations on classical set. We know the operation in classical set is union, intersection, complement. The union of two sets A and B is given as A union B, which is equal to X such that X belongs to A or X belongs to B. Intersection is nothing but the intersection of two sets A and B is given as A intersection B, which is equal to X such that X belongs to A and X belongs to B. And the complement, which is denoted by A bar, which is defined A bar which is equal to X such that X does not belong to A and X belongs to capital X. That means the element is not in A, capital A, but it is in capital X. Next, fuzzy set. Fuzzy set theory is an extension of classical set theory. The elements have varying degree of membership, a logic based on two truth values. Truth values you know, that is 0 and 1, that is true and false, is sometimes insufficient when describing human reasoning. Fuzzy logic uses the whole interval between 0, that is false, and 1, that is true, to describe human reasoning. A fuzzy set is any set that allows its members to have different degree of membership called membership function, having the interval that is close to interval 0, 1. Fuzzy logic is derived from fuzzy set theory. Many degree of membership between 0 to 1 are allowed. Thus, a membership function mu A of X is associated with a fuzzy element of set A bar such that the function maps every universe of discourse capital X to the interval 0, 1. The mapping is written as mu A of X such that X belongs to 0, 1. Fuzzy logic is capable of handling inherently, that is vague or inexact or rough or imprecise or inaccurate concepts. Fuzzy set is defined as follows. In mathematically, if X is an universe of discourse and X is a particular element of capital X, then a fuzzy set A defined on capital X can be written as a collection of ordered pairs A which is equal to X, mu A bar of X, which is X belongs to capital X. Example of fuzzy set. Let us take capital X which is equal to G1, G2 and so on, and G5 be the reference set of students. Let capital A bar be the fuzzy set of smart students, where smart is fuzzy term. very closely, very excellent. All these are the fuzzy terms. A bar which is equal to G1, 0.4. This 0.4 is nothing but the grade, that is the membership grade. G2, 0.5, G3, 1, G4, 0.9, G5, 0.8. That is, the student G5 having the membership grade that becomes 0.8. Here A delta is indicates that the smartness of G1 is 0.4 and so on. Membership grade. What is mean by membership function? The membership function fully defines the fuzzy set. A membership function provides a measure of the degree of similarity of an element to a fuzzy set. Membership functions can either be chosen by the user arbitrarily based on the user's experience. Two users could be different depending upon their experience, etc. Or be designed using machine learning methods, that is artificial neural networks and genetic algorithms, etc. Fuzzy sets. There are different shapes of membership functions, that is triangular shape, trapezoidal shape, Gaussian, etc. First one, triangular membership function. A triangular membership function is specified by 3 parameters. Tri means 3. Here we will taking A, B, C. A, B and C represent the x coordinates of the 3 vertices of mu A of x. In the fuzzy set capital A. A is nothing but the lower boundary and C is upper boundary where membership degree is 0 and B the center where membership degree is 1. Mu A of x, that is equal to 0 if x is less than or equal to A. So in figure mu A of x, in figure the membership function, it is noted A, B, C, taking as the triangular shape. So it is called triangular membership function. 0 and 1 is the fuzzy intervals. Next, trapezoidal membership function. A trapezoidal membership function is specified by 4 parameters A, B, C, D as follows, that is mu A of x which is equal to 0 if x is less than or equal to A, x minus A if A is less than or equal to x less than or equal to B, and B minus A if B is less than or equal to x less than or equal to C. Another one, D minus x if C is less than or equal to x less than or equal to D, and D minus C, D minus C, D minus x, all these are if C is less than or equal to x less than or equal to D. 0 if D is less than or equal to x. The next Gaussian membership function, that is mu A of x which is equal to the exponential of the given set. That is C which is here, the C is center and S is width and M is specification factor. That is, for example, we will be taking M equal to 2. The membership grade figure is given, that is M equal to 2, S equal to 2 and C equal to 5. Another one figure, that is M equal to 2, S equal to 0.5 and C equal to 5. It is crucially drawn. Another one, M equal to 2, S equal to 5 and C equal to 5. The next figure, if M equal to 0.2, C equal to 5 and S equal to 2, and M equal to 5, S equal to 5 and C equal to 5, the different shape of graphs. The next, fuzzy set operations. Given X to be the inverse of discourse and A bar and B bar to be the fuzzy sets with mu A of X and mu B of X are their respective membership function. The fuzzy set operations are as follows. The first one, union. Union, that is mu suffix a union b of x, which is equal to maximum of mu a of x comma mu b of x. That is, we will take maximum number of membership values. Here we will take maximum value. In intersection, we will take the minimum value, that is mu of a intersection b of x equal to minimum of mu a of x comma mu a of b. Sorry, mu b of x. Another one, complement, that is mu a of x, which is equal to 1 minus mu a of x. Next, fuzzy set operation. Example, a, it is given a equal to x1 comma 0.5, x2 comma 0.7, x3 comma 0. B is nothing but x1 comma 0.8, x2 comma 0.2 and x3 comma 1. Now, we will take the union of these two elements, that is A and B. A union B, which is equal to x1 comma 0.8. How will you take? That is 0.8 grade, that is x1 having two elements. In A, it is 0.5. In B, it is 0.8. So, which is maximum? Here, the maximum is 0.8. In union, we will be take the maximum element. So, x1 comma 0.8. The next, x2. So, x2, the maximum element is between 0.7 and 0.2. The maximum element is 0.7. In x3, here given 0 and 1. The maximum value is 1. So, x1 having 0.8 maximum value, x2 having 0.7 and x3 having the value is 1. So, maximum of mu a of x1 and mu b of x1, that becomes maximum of 0.5 and 0.8. So, that is equal to 0.8. This is the answer. The next one, intersection. So, the same example. So, intersection A intersection B. Here, the minimum value will be taken. That is mu A intersection B of x1 value. X minimum of mu A of x1 comma mu B of x1. What is the value of x1? x1, that becomes 0.5 comma 0.8. Here the minimum value will be take 0.5. That is minimum. So, minimum of 0.5 and 0.8, that becomes 0.5. Are they the same? In x2, the minimum value is 0.2. In x3, the minimum value it becomes 0. The value it becomes 0 comma 1. So, 1 is the larger one, 0 is the minimum. So, it will be take x3 value is 0. The next example, complement. That is A, which is having x1 comma 0.5, x2 comma 0.7, x3 comma 0. So, the complement it becomes A complement, that becomes x1 comma 0.5, x2 comma 0.3 and x3 comma 1. That is mu A of 1, that is the complement of x1, that becomes 1 minus mu A of x1. That is the formula. 1 minus mu A of x1 is the complement of mu A of x1. That is equal to, that is 1 minus 0.5 is nothing but 0.5. The same will be followed. 1 minus 0.7 is 0.3 and 1 minus 0 is 1. That is x2 value and x3 value. This is complement. The next is support. What is support of A? A is any one of the set. The support of A is the set of all points x in capital X, Z, x is that mu of x is greater than 0. All are positive values. All values are A nearing. All positive values are the support of the A. The next core A is the set of all points x in A. Capital X is z. X is z mu A of x, which is equal to 1. That is core A of A. Then with mu A of A equal to 1 is called fuzzy singleton set. Fuzzy set whose support is a single point in capital X. So this is the figure. Lower boundary, support and upper boundary, core. All these are present here in this figure. The next, linguistic variable and linguistic term. Linguistic variable. A linguistic variable is a variable whose values are sentences in a natural or artificial languages. For example, the values of the fuzzy variable height could be tall, very tall, very, very tall, somewhat tall, not very tall, tall but not very tall, quite tall, more or less tall. Tall is a linguistic value or primary term. Here the linguistic variable is only the tall. If age is a linguistic variable, then its term is T of age, which is equal to young, not young, very young, not very young, and so on. Middle age, not middle age, and so on. Old, not old. All these are the linguistic term of the age. Next, fuzzy rules. Fuzzy rules are useful for modeling human perception, thinking, judgment, that is opinion, value. And a fuzzy if-then rule is of the form: if x is in A, then y is B, where A and B are linguistic values defined by fuzzy sets on universal of discourse x and y respectively. If x is in A, it is called antecedent, and y is B is called subsequent. Example for such a rule are: if pressure is high, then volume is small. If the road is slippery, then driving is dangerous. If the fruit is ripe, then it is soft. Binary fuzzy relation. We are going to see the binary fuzzy relation. A binary fuzzy relation is a fuzzy set in capital X cross Y, which maps each element in X cross Y to a membership value between 0 and 1. If X and Y are two universes of discourse, then R, which is equal to, that is relation R, which is equal to x comma y, mu of x comma y, is that x comma y is belongs to capital X cross Y. Is a binary fuzzy relation in capital X cross Y. Here, x cross y indicates Cartesian product of x and y. The fuzzy rule: if x is A and y is B, may be abbreviated as A tends to B and is interpreted as A cross B. A fuzzy if-then rule may be defined as binary fuzzy relation R on the product space X cross Y. If R equal to A to B, which is equal to A cross B, that is equal to integral of mu of x, T norm of mu of y is z, which is belongs to X cross Y. Thank you.